So let's do number 5. If you do number 5 and balance it out, you'll see something like this. Now, I actually forgot to write the question for B, and B asks something like, what is the mass of iron 3 oxide needed? So what is the mass of that needed to produce 15 grams of this? Okay. Now, again, this isn't a limiting reagents problem. This isn't like, you know, I give you 2 masses from the reactants and ask you how much is left over and how much of this did you produce. No, I gave you how much of that I produced. I want to know how much did I start with. And again, I don't care about anything else. I'm only asking you between this and that. So this is a really simple problem too. I just start with what I know. I start with 15 grams of iron because that's what I know, right? To be sure. I want to know that. I don't know anything else. So I need to get rid of grams of iron somehow. And how am I going to do that? I look at the periodic table, remember? If I don't know the grams, according to my periodic table, that's the mass of iron per 1 mole of iron, okay? Then everything's canceled out except for mole of iron. Here's where I get to the ratio between what is known and what is unknown, because I only have 2 factors here. According to my problem, every time I have 2 moles of iron, I'm only going to have 1 mole of iron oxide, according to my problem that's been balanced, right? So that cancels and that cancels. So now, because I want to know in terms of grams, I want to know the mass, I just have to figure it out like this. If I have 1 mole of iron 3 oxide, then how many grams of it is that per 1 mole? And if I figure out how many moles of there are, then I can just multiply straight across. And if I do that, then I'm going to get, this one is a molecular weight I find from the periodic table. And I kind of already found it there for you. So if I multiply straight across and divide it by whatever I multiply straight across down here, then I should get something like 21.4 grams of iron 3 oxide, okay? Then C is asking you, then how many aluminum atoms are needed to react with that much of iron 3 oxide? So again, you start with what you know. 15 grams of iron oxide is what I know, okay? Then I have grams of iron oxide down here, right? So what goes here is the molecular weight, so it's 159.7. And then I say, okay, so that cancels, that cancels. I have 1 mole of iron 2 oxide here. Then I have to say, okay, according to my reaction, what is the ratio? I have mole of iron oxide here, so I need to put mole of iron oxide here. I see I have 1 according to my reaction. Then how many of those do I have every time I have 1 of this? How many moles of aluminum do I have in my reaction? And the answer is 2. I have 2 moles of aluminum, okay? So that cancels and that cancels. So then I have to say, okay, if I have moles of aluminum here, I need moles of aluminum down here. So every time I have 1 mole of aluminum, how many particles do I have? The answer is 6.02 times 10 to the 23 particles, or rather atoms in this case, right? Then that cancels and that cancels. The only unit I am left with is atoms of aluminum here. Okay, so I know I'm on the right track. So again, all you have to do is multiply that straight across and divide it by that, and your answer should be something like 1.13 times 10 to the 23 atoms of aluminum.